Hello everyone. So if you're watching these in the suggested order, obviously you can ignore my advice completely, but if you're watching these in the suggested order, you've watched some real life storm chaser footage of a storm surge. I would like to think that that is the closest you are ever going to get to experiencing one. I think it's amazing footage, but I think I'd have been so frightened. So hopefully that set the scene for you a little bit. This video is my explanation, which I suggest comes second. And it accompanies pages 58, 59 and 60 of your module booklet. Okay, so they are the two links I sent you yesterday. This is what you need to know. So you might get asked a question about storm surges. Fine, straightforward. You might be asked a question about coastal flooding. Now, you've probably heard of flooding, particularly if you live near the Somerset levels. That's river flooding. This is a different type. So river flooding is to do with rivers being overwhelmed by amounts of rainfall, runoff, all of that stuff we learned about in the water cycle. This is a different kind of flooding, and it's essentially when the sea comes onto the land, which is not ideal. So it's just important to differentiate that it's a completely different kind of flooding to the type that you get from too much rain. We are going to have a case study of this. I've done a case study video for you already, and I have said you don't necessarily need to worry about Hurricane Katrina at this point, because Hurricane Katrina comes up in year 2 as well. I think it's a fascinating case study, and personally, I think if you do have a little bit of time on your hands, I don't know your personal situations, but if you do have a little bit of time, I would be watching a few documentaries and stuff. It's a really, really interesting case study. Okay, so I am going to try and explain to you what they are, what happens. And you can see you've got two diagrams in front of you. It's different to the version that you've got on page 58, but it's the same basic principle. What happens in a storm surge is that the depth or the height of the sea increases. So if you look at the top diagram, you can see everything's fine. And if you look in the bottom diagram, there is a little bit of a problem. So the actual water level rises. Okay, and as you can see, you'd be much more at risk of these if you lived in the tropics, because sea levels can rise by up to 8 metres, which is ridiculous. But we do get storm surges in and around the UK and Europe. They're just smaller, and my job is to try and explain to you what causes them, and then the difference in height will hopefully make a little bit more sense to you. So they're basically where the height of the sea increases. Now, I can't draw at the best of times, can I? It turns out I really, really can't draw using a computer mouse. Apologies. Right, above your head there is this thing called the atmosphere, and it's a layer of gases surrounding the planet, and it's the reason that you exist, pretty much. It's a really important thing. Now, that layer of gases above your head is exerting pressure. Okay, and we really study this in year 2, and you will probably get what I call a light bulb moment where people go, oh gosh, all of this weather I've experienced for my whole life suddenly makes sense. Everything really in weather and climate is controlled by pressure. For now, all I need you to accept is that the layer of gases above your head is exerting a pressure on you, and whether the air is rising or falling is very, very important. All right, so in this situation where the air is moving towards the ground, so this is my attempt at land, this is my attempt at sea, the atmosphere is pushing down. Now, it doesn't really have much effect on the land because the land is a solid, but the sea is a liquid, and when the atmosphere is pushing down on the sea, it's kind of compressed a little bit. The molecules move closer together. However, if you have a low pressure system, so that's bad weather, that's any kind of storm. So if you have wind and rain, that's a low pressure system. In a low pressure system, the air is rising. that means there is nothing pushing down on the sea. And so the sea level actually rises. This is my attempt. So the red is representing what the atmosphere is doing, whether it's pushing down or rising. And then the blue is representing what the sea is doing. So high pressure is really nice weather. It's the weather we've been having for, oh gosh, ages now. No wind, no rain, a few clouds in the sky maybe, but generally really good weather. And that tends to make the sea level go down. Bad weather, sea level rises. So on average, the pressure of the atmosphere is 1013 millibars. Any number higher than that, high pressure. Any number lower than that, low pressure. Okay. So if I open up, and obviously if you decide to follow these hyperlinks, it will be different because this is live for the time that you are looking. This is a Met Office surface pressure chart. I don't expect you to make it to make too much sense to you, but just look at these numbers and letters in white. H for high, L for low, and you've got all these numbers. So that's what it means. It's whether the pressure is high or whether the pressure is low. Now you can see the UK is currently in an area of high pressure, which is why the weather has been so lovely. We would not be at risk of coastal flooding at all at the moment. And I can prove that to you by going on here. So this is the flood warning thing, which will also be live for the day and time that you look at it. We can't see any coastal areas at risk of flooding whatsoever because we're in a high pressure period, okay? So the absolute worst case scenario for storm surges or coastal flooding is where you have the high spring tide. Remember, the spring tide is when the moon and the sun are working together. So you get the highest high tide and the lowest low. So if you've got the highest high tide possible, and then along comes some kind of bad weather, so you get the low pressure, which means that your sea level rises, you've kind of got this double whammy effect, haven't you? You've got a high spring tide, the sea level rises because of the low pressure, and of course the other thing we know about low pressure systems, storms, is that's what creates our waves. And so what happens essentially is the sea level rises and then the wind pushes the sea onto the land in a series of waves. So they're pretty scary, awful things. And if you've watched the Storm Chaser footage, hopefully you've got a sense of that. And your diagram on page 58 gives you a sense of how big storm surges can be in relation to the average house size. And you can see these can be as big as tsunamis. I apologise that the scale is in feet, but if you divide by 3, you will approximately get the height in metres. These can be as big as tsunamis. The reason they happen is completely different, but they can be that big and they are incredibly scary. If you haven't seen the Storm Chaser footage, please watch it because it will help you. So we do get them in the UK, and if you've watched my case study video, you will have heard me talk about this. This is not officially a case study, but some of you might just be interested in it. In 1953, we had a really terrible storm surge. There's a little bit of information about it on page 60 of your module booklet. A little bit of information on the screen. And you can see just truly devastating. You know, look, there's half a house missing there. But your proper case study for storm surges is good old Hurricane Katrina. Very, very famous, very, very interesting. And it's kind of a worst case scenario, really. Hurricane Katrina hit New Orleans. So New Orleans is a city here. As you can see, pretty much surrounded by water. And yet if you have a look at the diagram on page 59, and I've got a version of it on the screen, most of New Orleans is below sea level. All right, just let that sink in. So we have a city that is surrounded by water and is largely below sea level. This is slightly idiotic, isn't it? Let's realise that. And the things that protect New Orleans and stop New Orleans flooding are these walls. These are called levees. And the idea is that they keep the water out and keep the city in, as it were. They are the barrier. Well, it doesn't take a genius to work out that if your levees break, because New Orleans is below the height of the water, what New Orleans does is it fills up like a basin. And that, ladies and gents, is exactly what happened in Hurricane Katrina. So we've got one of the, well, in fact, the richest country in the world at the time, the most prepared for hurricanes because they get them every year. And in fact, you can't criticise their planning for Hurricane Katrina. Well, apart from putting a city in a very stupid place, their planning for Hurricane Katrina was really, really good, but it all completely unravelled once Hurricane Katrina hit. And it's a really interesting case study in disaster management and what not to do. We usually say, don't we, in geography, more developed countries, hardly any deaths, less developed countries, loads of deaths. And Hurricane Katrina sort of changes that a little bit, so it's quite interesting. That is a clip that I would highly suggest that you watch. I'm not going to open the link. This PowerPoint I've been showing you today is in my Coasts folder, and it's actually called Storm Surges, ladies and gents. So it's pretty easy to find. That is not a particularly long video, and it's a day-by-day summary of Hurricane Katrina hitting New Orleans. It's brilliant. I know some of you are really busy, and in which case you haven't got time to do this. If you are getting to a little bit of a twiddling your thumbs phase and you're a bit desperate for things to do, then I thought I would just suggest a couple of other documentaries. The YouTube link for the first one can be a little bit temperamental. Sometimes it works, sometimes it doesn't. If you have any significant issues accessing that, just let me know and I'll have another search and see if I can get hold of it. And then the second bullet point is about some films and TV series. You have to just be careful of the age rating, ladies and gents, because most of them are 15s, but I think one of them is an 18, so please just be careful about that. But you can really get your teeth into Hurricane Katrina. Now there's a teeny little bit of information in your module booklet, bottom of page 58 and the diagram on page 59, but basically it's about either leaving it to year 2 or immersing yourselves in documentaries, because there's so many of them and they are brilliant. But, sorry, I'm going to go quite fast now. Apologies if it makes you feel a bit seasick. The most important bit of information, and the reason there is a space on page 59, is for you to get your head around this link between pressure and sea level, because that's why storm surges happen. Okay, and the combination of the sea level rising and the strong winds that you also get in storms is why this lovely normal situation in which this coastal property is all wonderful, everything goes wrong in a storm surge. Okay, so you may get a little bit stuck on those. Some people do find them a little bit confusing, and I can't say I blame you. It might be something that we need to cover quite a lot more in a YouTube live, in which case send me questions, ladies and gents. The only way I'm going to know that you're struggling with things is if you tell me, okay? But don't be embarrassed, because these are maybe a little bit trickier than some of the other things we've done in Coasts. Okay, email me if you need to.